Yo, what's up, guys? This is the third video in the collection. Um, so I actually recorded this, but then I realized I made an error, so I'm gonna record it again. So this time around is gonna be so flawless and seamless and just absolutely incredible. People are gonna really start calling me organic chemistry professor. Okay, so starting with number one here. What do we got? Oh, sorry. We got MCPBA. This is it's an epoxide generator. This is brand new lingo from yours truly. I don't even know. I don't know if like this is a molecule up here or like what the hell. But okay, we're just gonna use this molecule over here. And we're gonna turn it into an epoxide. So how do we turn it into epoxide? Well, thank you for asking. What we're gonna have happen is well, the double bond here. We're gonna use it to bond to the oxygen. And we're going to get something like this. And then also the methyl group is also there. So we're going to get that. Plus, remember this is a syn addition reaction. So we're going to attack from both faces, giving us and then this is going to be our methyl. So we get a pair of enantiomers. Okay, and now looking at the stereochemistry. So we're going to do this first over here. 1, 2, 3 in the order of priority, and then we're going to also have H in the back, which is going to be 4, which means that we have R over here, and over here we're going to have, let's use a different color, 1, 2, 3, so 1, 2, 3, this looks like it's going to be an S, because methyl would be our 4th priority, get an S right there. Okay, now moving on to the other one, since it is a syn addition, it's very, very easy to determine the stereochemistry. All we're going to do is basically just flip it. Very easy, and that will be our stereochemistry. Okay, for our next example, we have NaOH, so a strong base. It will dissociate into OH minus and Na plus. Na plus we don't really care about because it's a spectator ion, but now we have OH minus in solution. So OH minus in solution, what can we do to this molecule? Well, right off the bat, I can see that we have an OH group down in the bottom left, and with OH minus with strong base, we can pry off the oxygen and create an epoxide. And this is also bromine, a good leaving group on the right side, but we have to line them up first to begin. So we're going to do that. So we're going to have OH methyl hydrogen. We're going to have bromine up here. Oops. And then that. So now that we move bromine up here, we're going to have methyl over here and hydrogen over here. Okay, and remember there's a bond between the hydrogen and the oxygen. Okay, next, so we have our strong base, so OH minus. We're going to attack the hydroxy group on this molecule. Oops. And so when we do so, we're going to basically move the electrons in the sigma bond onto the oxygen, making it negative. So we're going to get something like, oops. We're going to get something like this, OH minus. And now that we have this OH minus, we can probably do the epoxide making now. So first thing that I can see is that we're going to have a negative charge on the oxygen over here, a partial like negative charge just because the oxygen is very electronegative, and we're going to have a partial positive charge on the carbon on the other side. what we can do there is build a bond. Oops. Yeah, this can all go, oops, a little bit too much. This is there, this is there. So we're going to build that bond. And in doing so, we're going to take the electrons from the sigma bond of the bromine sigma bond, put it onto the bromine. So bromine is going to leave. And then we're going to get an epoxide forming. Oxygen there. This is also methyl, lost the E somewhere along the copy and pasting line there. Okay, but now we have our epoxide over here. Now looking at stereochemistry, this is a methyl up here. So looking at the left carbon, we have 1, 2, 3. So 1, 2, 3, it's going like an S, and hydrogen is in the back. And then on the right, we're going to have, choose different color, 1, 2, and 3, which is going like an R. Okay, and that's example number 2. Okay, and our last example for today, number 3, we have a nucleophile here. And we don't know what the hell it is. But our nucleophile has electrons. They're all, and we're also in basic conditions. So we're going to have regioselectivity, and we're going to favor the least substituted carbon atom. So which one is the least substituted? Well, looking over here, we have a tertiary substituted and then a secondary substituted over here. So we're going to attack this carbon right here. So our nucleophile is going to come in, and it's going to be an SN2 attack. So we're going to attack from the face, which is in behind, so like this face over here. And it's going to give us this. Oops. Yeah, so our nucleophile comes in. The electrons in the sigma bond of the oxygen and carbon will pop up onto the oxygen. So we're going to get a negative charge on the oxygen, draw all the octets here. And then we're also going to have our nucleophile now on the back side because we had a SN2 reaction. And let's look at the stereochemistry now. So this is going to be our product here. I do want to address, so since you can see we have our oxygen here has a negative charge, the only way that we can give it like a not a negative charge would be if we had something else in solution to do so, like we had like hydrogen ions in solution, for example. Then we would be able to protonate the oxygen and remove the negative charge. But in this case, I'm just gonna assume that it's only the nucleophile, so we don't have any free-floating hydrogen ions in solution. So this is going to be our final product. Stereochemistry. So on the left carbon, we have 1, 2, 3, and then 4. So it's going like an R, and our lowest priority group is already in the back, so we don't have to flip it. And then on the right, we're going to have, so let's assume the nucleophile is it's like an oxygen-containing group. I'll use black to do this. So we're going to have 1, 2, and then 3. And then since our highest priority group is in the back and our lowest priority group will be in the front, which is hydrogen, we're going to have to flip it. So right now we're going like an S, but we're going to be going like an R. That looks good. Yeah. Okay, well that's it for this lesson today. We'll see if I get the stats, hypothesis testing later. We'll see. Okay, well, see you on the flip side. Oh, shoot. Oh, shit.